If I want the midpoint, it's very simple. You look at the two endpoints. Here's an R and an S, my endpoints. 1, -3, 4, 2. And I average. By average, I mean take the mean, add them up and divide by 2 to find the x-coordinate. So to find the x-coordinate, add the 1 plus the 4 and divide by 2. Like this 1 and this 4, divide by 2. To find the y-coordinates, you average them. So you add -3 plus 2, divide by 2. Let's see what we get here. 1 plus 4 is 5. Well, 5 halves, that's what I get. -3 plus 2, what's that? -1? -1 half? Hopefully I didn't make a mistake. That's the midpoint. So if I want to actually find it, it might be a little easier maybe to look at this as a decimal. So okay, 2.5, 1, 2, 2.5, go down a half. That works. I'm there. So average the x's, average the y's. Average the x's, average the y's. So we do have a generic formula, which is following here. This is the generic formula. So it looks complicated. A lot of these formulas look complicated. So I'd like you to kind of know exactly what you're doing. This is just take the two x's, add them, divide by 2. Average the x values. And this one, y1 plus y2, divide by 2, you're just averaging y values. That's it. And you found the midpoint. That's all you have to do. It's easy. Right? Good reading. Okay, so let's look at an example here. This is kind of near the bottom on the right, this particular example, hopefully you're following along. So I'll get the midpoint of JK is midpoint 2, 1. One endpoint is J14, find the other one. Okay, so let me just draw a picture of what's going on here. So let's see, the midpoint now. 1, 2, 1. That's M, the midpoint. One endpoint is J14, so 1, 2, 3, 4. Find the coordinates of the other endpoint. I'm going along there, and somewhere over here, going in equal length, going here, down here, someplace down here I have another endpoint. So now I have to find it. I have to find this endpoint K. How can I do that? What do you think, Isha? Use slope how? So this has a slope of what? 1, 2, 3, 1. So it has a slope of -3. So you're saying I can go down -3? How do I know that that's the midpoint? Well, you didn't average it. You just said find the slope, and here's it. So this is definitely another point on the line. I completely agree with you, using what we remember about slope. But how do I know that when I connect this, whoops, not a very straight line here, that this is the midpoint? How do I know that this piece is equal to that piece? How do I know that? How do I know that?
You can do what you did to find the midpoint, and you can add both points up and down.
So use this to help us. Use this to help us. You want us to verify. So if I was to say, what point is this? 1, 2, 3, 1, 2. So this looks like 3, -2. Just see if it works. If you average 3 and 1, do you get 2? Well, 3 plus 1 is 4, and 2 is 2. -2 plus 4 is 2. Divide by 2, I get 1. So it verifies. So that's how we got there. Great. So that's a method, is to try and use slope and then verify. What about if I don't have my nice picture here? And I'm not really sure how to, work with the slope. And all I've got is my formula. Is there another way I can think about it? What do you think? Is there another way to think about it?
If you add 1 to, if you add the formula 1 4 to the other xy, sometimes the average is equals to the
Okay, so you're kind of saying use this formula to our advantage somehow. How can we use this to our advantage somehow? Yeah.
1 plus x over 3 equals
Yeah. He's doing it. What I'm going to do is a midpoint. I have that information, it's this. So if I can use these formulas, x1 plus x2 over 2 gives me this. So what does that mean? If I add these two and then divide by 2, so that means that x plus 1 divided by 2, it has to be this 2, doesn't it? That's the formula. Do we see that? I'm just averaging this plus this, dividing by 2, and I should do that. What about with the y's? What's that going to look like? What's that going to look like? Excellent. Right, so we're just using the formula, but now we have to solve for this. And this looks like a little bit on that prep time. Like, do we know how to solve something like this? Do you know how to solve something like that? How do we do that? Right, so knock this guy out. X plus 1 equals 4. So my x is 3. Okay, so that's 3. And then I'll do the same thing here. Multiply both sides by 2. Subtract that 4. Getting 3 minus 2. It's the same thing that you got using slope. So it works. I mean, either way works. But this is kind of nice. Pure algebra. I don't need the picture if I don't want it. Or I don't want to use that, and the algebra will get me there. So 3 negative 2 will be the other one. When you get midpoint questions, be reading them really carefully. What are they giving you? If they're giving you 2 endpoints, then just go ahead and average the x's, average the y's. If they're giving you 1 endpoint and a midpoint, and you have to find the other endpoint, you have to go through this kind of thing. Does that make sense? Who's with me? You ready? All of you, that's fantastic. Okay, so we have some U-tries coming up. Go ahead and give these a go. So if I've got a horizontal line right here and here, what's the length? I'm just counting boxes here. Right, that length is 4. What if I have this as a possible line segment? 1, 2, 3, 4, 5. This length is 5. Not so bad. It's a little bit harder if I'm not right in a box, like something like that. Kind of falls apart a little bit. That's a little bit harder. And also, if the lines aren't horizontal or vertical, I can't count boxes anymore. So if I have this and this, I can't count boxes. I don't know. So we're going to use the distance formula. The distance formula, when you see it, is scary looking. It's frightening. It frightens me sometimes. So I like to know where it comes from, and then I don't have to worry about it anymore. Now, the Pythagorean theorem is another thing that we tried to go through in all the algebra classes last year. Did anybody remember getting a little talk on the Pythagorean theorem last year? You did? Yes. Okay, good. So a lot of teachers were able to get to it, which is great. The Pythagorean theorem states, in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. Remember what a hypotenuse is? It's the side opposite the right angle. This is the hypotenuse. So we're always using that as our equal base. So what I want to do now is I'm going to use the symmetric property of equality, which just says equals, you can turn them around. And I want to solve for c. How do I solve for c? Because I got c squared. So what do I do? Find square root of c. What's the square root of c squared? C. What's the square root of a squared plus b squared? I don't know. That's the best I can do. Is it a plus b? It's not a plus b. It doesn't work that way with plus. Right? If these were multiplied together, that's when you could take the square root of each side, but plus doesn't work that way. You can take a simple example and plug it in and see that it doesn't work. This is basically the distance formula. C equals the square root of a squared plus b squared. Now, what's a? A is one side of a triangle and B is another side of a triangle. So if this is my line here, that's what I want to find the distance of. What you do is you imagine the right triangle formed. This is like the A, and this is like the B, and that's your C, your distance. That's what we're trying to find. So again, that ruler postulate is really going to help us here. How do you find this length? When you take this x value and you subtract that value. That's going to give you a length for the x. And the y, you take this y value, subtract that y value, and you're left with your y value. So let's just look at an example. I think that's what I have next. Let's see. Well, this is the actual formula. Again, complicated looking. All it's saying is the length of x squared and the length of y squared. And I'll show you how it works in an actual example here. Okay, So here I've got segment RS. R is 2 comma 3, S is 4 comma negative 1. So we can look at x1, y1. Let's make this one x1, y1. Let's make this one x2, y2. On the back here, hopefully you're following along. So what's x1, y1? I'm calling that one 2, 3. X2, y2 is 4, negative 1. This here is that ruler postulate saying what's the length of the x's? And what do I mean by that? If I were to complete this triangle, that's like my A, and that's like my B. What's the length of A? It's the distance between 2 and 4. What's the distance between 2 and 4? What is it? 2. You can even see it here in the boxes. It's 2 away. What's the difference? Now careful now, because this one's the length of the y. What's the difference between 3 and negative 1? Careful now, picture like a number line. You've got 3 and then there's a negative 1. What's that distance? What is it? What do you think? 4. She's right. And look up here. 1, 2, 3, 4. Negative 1's down here, 3's here. So does the formula work? If I take x2 minus x1, that would be 4 minus 2. Well, that's 2. What about y2 minus y1? That's negative 1 minus 3. That's negative 4. What distances? Do we have negative distances? No, distances are negative. We always take the absolute value. So that distance is 4. It's 4 away. So now what I want to do is, again, this is complicated looking. I think about my c, which is my distance, I'll call it d, square root of this side squared, that's 2, right? 2 squared, plus the distance of this one, 4 squared. And now I can figure out what I got here. That is square root of 4 plus 16 equals square root of 20. Now here's the thing, can I leave it like square root of 20? No, we can't really do that. So we have options here. If they want exact distance, exact, you would just reduce this. How do I reduce square root of 20? What do we get?
Try to make it square.
Which is what?
4.
So I can take that out. So 2 square root 5, right? Is that the same as square root 20? That's if they want, give me the exact distance. That's what you said, because that's exact. Give me an approximation, that's where your calculator comes in. You can type in either square root 20 or 2 square root 5, either one, it's approximately to the nearest 4.5. So this is kind of like an approximation. Real life problems, we tend to use approximations because we don't think in radicals in our head. Most of us don't anyway. And that's really the distance formula. Remembering that a squared plus b squared equals c squared. A is your length between the x's, and y is the distance between those, the y values. There you go. That's about another example. Everybody, you try, because I think you can do this. So I'll just get you started on this one. Complete the triangle, because I think that'll help you see it. Right? If that's A, and that's B, and that's C, what?
You're going down.
You can go up. You can go up, sure. A squared, what's my A? What's the distance between 1 and 5? What's the distance between 1 and 5, right? 1 and 5. How far apart? How far apart? So 4, square it. What's the distance between 2 and 4? 2, square it. You're all set up. And this comes out to be just like the other problem. You're getting the square root 20 again. Put it in radical form, simplest radical form, and also give me an approximation. So please go ahead, try the other one, and see how that goes. Remember there's negatives here, so be careful when you imagine the distance. You can draw the little boxes if that helps you kind of see how far is the x's, how far are the y's.